All right, welcome to another video lecture. Here we are. This is going to begin with chapter 20, and I would say this covers along, first 2-3 sections, We'll look up, probably up to 20.3. We'll look at it, we'll be looking at it again. So, circuits. We're going to look at different ways on looking at circuits. First, how to draw them and what they are, and we'll go through that. So, here's a battery. A battery is what provides energy to a circuit. You can also have plug it into a wall to have for an alternating current, which we'll get to in a second. But we're going to look at direct current, DC circuit. So battery is what provides energy to them. We've talked about voltage or electric potential as the energy per charge. So we have the idea here that these little blue things are kind of the charges moving within a circuit. And what we have when we create a circuit, and let's build a circuit right here. So I'm going to take some wires. I'm going to connect these wires here to this battery. And we have these little blue things. Their ideas are charges. These are the charges moving in the wires. I got my nice little pretty circuit here. And I have my light bulb. I'm going to attach my light bulb and kind of move it over here. And one last wire. And boom. There goes the circuit. The circuit's moving. Now if you notice, the electrons, they're moving out of the negative side of the battery. So this is the positive side up here. We say the current flows from positive to negative. That's because we used to think that the positive charges in a circuit were the ones that move. We now know that it's the negative charges. So what a battery does is, as a charge, you can kind of think of it moving through the battery, it gains some energy. It gains some energy and then it moves down through the wire. And it's not so much as the whole charge moving through the wire. It happens eventually as it goes through, but there is more that it's just transferring that energy onto another electron. So it's bumping into another electron and transferring it down there. There is some flow, and there's a lot of flow of the electrons, but it's not so, there is more that the collision aspect there. Now, so some charge has some value of energy, and it moves through here. And once it gets to something that is a resistor or a usage, a motor or anything like that, it's going to convert that energy into another form. And we have, so this light bulb here is taking the energy per charge and converting it into light. Now if I add my voltmeter here, measures voltage. So we see here that this battery, if I attach it here, it measures the potential difference between two places. So the potential difference between here and here is 9 volts. So that's 9 joules per coulomb. So that as the charge moves across here, it gains 9 joules per coulomb. If I were to switch the terminals, it's going to be negative 9 volts because now we're opposite there. So it's negative 9. So it's actually gaining negative 9 volts as we're gaining 9 volts of energy as it crosses here, joules per energy. Now, if we look over here, so we say 9 volts of energy, or actually we should say like that. And then we look over here, there's a voltage drop. This is what we're calling, there's a voltage drop across this light bulb here, which ends up being the energy used. And it happens, in this case, equal the voltage of the battery, because all the energy is being used by the light bulb as it goes around the circuit. Now, let's stop this for a second here, or let me just split this junction here. Nope, go over here. And I'm going to add a second light bulb and spin you around. So now I have 2 light bulbs. Each light bulb, if you notice right now, they're a little bit dimmer. Kind of hard to tell right now, but they're a little bit dimmer. So we look, battery still supplying 9 volts of energy. Notice how the charges are moving a little bit slower than they were before. We'll talk about current in a second. Across each light bulb, there is now a drop of 4.5 volts, this voltage drop, because this is still the energy getting used by the light bulbs is going to be equal to the energy supplied by the battery. When a charge and this is a very important idea. When a charge leaves a battery, all the energy must be used before it returns to the battery. So the voltage drop across any path that comes across and we'll talk about different types of path parallel and get a little different, but the total energy must be used no matter what path it takes. So let's stop here for a second and pause. Here we go. And you know what I'm just going to do is I'm going to just connect it here. Boom. We have a short circuit. This is a short circuit. There is no resistance to the flow of electricity. Now, within the wires that we're using, we're saying, and I'm pausing it right now, we're saying that the flow of the wires have a zero resistance, so they're not going to resist anything. What resistance is, it's the ability to use energy or convert it into another form. So when we put this is a actual resistor here. We'll put it in there. It is converting energy provided by the battery. In most cases, what resistors do is they convert energy into heat or other, really heat. Light bulbs converted heat and light. Motors converted into kinetic energy, etc. as we go through there. And we have here. So this is our simple circuit right here that we have so far with a resistor, a battery, and this. So voltage is the energy per charge provided by the battery or provided by some energy source. It's the energy per charge, and we'll talk more about what EMF is tomorrow night. And then resistance is the ability to convert that energy into something else. It's to convert that energy into another source. Current is the rate at which charge flows. It's measured in amperes, which is a coulomb per second. So if I take a ammeter, non-contact ammeter right here, and I move it over the wire, that means that there are 0.9 coulombs of charge passing by this point every second. So 0.9 amps is 0.9 coulombs of charge passing through this point every second. So this is what an ammeter. The way that you really need to connect an ammeter to measure current, and let me drag it out here. I'm going to split this junction, is you need to have it set into the wire so that the current passes through it. With a voltage, and this is the voltage meter over here, you need to measure the potential difference between two places. So there's and the dials that we'll use, there'll be different settings on the actual meter here that we'll go through and use. Let's see here. Where am I? All right. Let me pause. I'm going to reset. All right. Yes. Delete the voltmeter. Delete the ammeter. And now I want to schematic. And here we go. So here is a battery. This is the symbol here for a battery. It is, this side refers, and if we can go back to lifelike, positive side, negative side. In the schematic, the positive side is bigger and the negative side is smaller, like that. And you can have multiple batteries connected like this. So this would be, if each battery is 9 volts, we'd have a total potential gained across this point of 27 volts. A light bulb. They have a crappy drawing for a light bulb. Excuse my language. I don't know if that's even a bad language to say crap, but whatever. I don't like their drawing for that, for a light bulb. Ignore this. It's 3 little loops with a circle through it. Not very creative. Here is a wire for a resistor. So here is the simplest type circuit right there. Simple circuit. Normally, when we draw circuits, we draw everything. All the wires are straight lines. So we have straight lines like, swing, you silly thing. This is so aggravating right now. Ah! Split junction. There we go. And now, so we'd have a schematic would look like this with the lines completely drawn. One other thing I can add in here is a switch. We'll throw in my switch right here, control split the junction, and we'll go switch. So we have, in this case, we have a closed, this is actually, excuse me, an open circuit, and then what I'm going to do is I can take it down, and boom, I close the circuit, and there is current flowing through the circuit now. So, once again, voltage is the potential difference or between 2 points, or it's the energy per charge. Current is the flow of electric charge in a circuit. It's the rate that charge is flowing through there. Next is resistance. Excuse me. Wow, I spaced out for a second. Resistance is the ability to convert energy into another form. For Monday, for class, whether it be, I mean, I'm creating this video for the future, so it may not actually be Monday that people in the future are not watching this, but we'll see. For next class, please make sure and rewatch this or look it up in your book about how to measure voltage, current, and resistance, how to measure them within a circuit, because that's what we will be doing in class in Monday. You will be constructing circuits and drawing schematics for them. So look here and try and make sure you have all these symbols written down in your notebook. Thank you very much. Have a good night. I will see you next class, probably Monday.